Hello, good afternoon, everyone. Dear authors and invited guests, welcome to the technical session 7C. My name is Siddhi Auti and I'll be your session moderator for today's session. On the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 9th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2025. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held via Zoom meeting today and tomorrow on 30th and 31st Jan 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, in total, we will be having 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. On 7 minutes, I will be raising a gentle reminder. There is also another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, just before we start the session, I would like to introduce you all to today's session chair, Dr. Upesh Patil. Dr. Upesh Patil is working as Associate Professor and Head at Charusat University, Gujarat, India. He is involved in teaching at UG PG level. His areas of interest for research include commercial antenna design, RF and microwave engineering, digital signal processing. He has published several research papers in international journals and conferences. He is member of IEEE Antenna and Wave Propagation Society and Indian Society of Technical Education. Welcome, sir, for today's session. Now we'll proceed with the presentations. So the very first presenter we have here today is Raghunandan KS from New Horizon College of Engineering, India. And the paper title is presenting on is a survey on fire alarm systems, technological advancements and challenges. I request Raghunandan KS sir to please proceed with your presentation.
Uh, one sec.
Hello,
Hello.
Raghunandan sir, if you're there in the meeting, please give us a
Yes, yes,
response.
I am in the meeting. One second.
Okay.
Hello, can you see my screen? Can you confirm, please?
Yes, sir, we can see your screen.
Thank you, thank you. Good afternoon, everyone. My name is Raghunandan KS and presenting my paper titled "A Survey on Fire Alarm Systems, Technological Advancement and Challenges." We wanted to focus our paper based on a few key issues. One of the issues was Bellandur Lake fires, which happened recently in Bangalore. The lake fire was caused due to excessive pollution and dumping of waste materials into the lake, which caused a chemical fire to occur and basically costed the government a lot of money to keep out. Our paper was our paper was made to made that so that we can prevent this. So first, the smart lake monitoring system. We are thinking of using advanced sensors on all part of the lake so that we can detect fire in the early stages and we can send SMS to all the stakeholders like the fire department and all others. And we can also detect any abnormalities like smoke very early, and we can use AWS so that AWS to send the data to the cloud to analyze it to make sure that false positives does not occur. And we have also thought to making it scalable, cost effective, and effective design. So our basic goal was to design a fire prevention method in lakeside environment. One of the main hurdle was there was there were uh, very difficult to design in lakeside because of that environment beside it. So they This is not. So one of the main sensor-based approach, we were planning to use temperature sensors and smoke sensors, and also so that we can detect rapid temperature increase deployed in fire-prone areas, and also smoke sensors to identify smoke particles and ensure timely action. So then we thought of integrating all of them into IoT and make sure we have real-time monitoring so that anyone can see it in their command center. And one of the main goals was also to no, false positive. We wanted to prevent it. Uh, Methodology was imagine we have a lake, and then we made it so that we have sensors on all places of the lake side, and after that we will set up AWS server so that it can receive the data from the sensor, and we can process the data. So we actually designed a small model that took data from sensors and uploaded it to the AWS cloud, and we got the finished model where we can see the output of the data. Uh, as you can see, this is the model of our project. So this is also in very early stages, and we can still improve it to make sure that IoT and cloud technology is used further, and we also like to do more research so that we can further detect any more fires and make sure that all the stakeholders have been notified correctly, and we also want to make it cost effective and make sure that basically increase the safety all around. So one of the way we will do it is to integrate machine learning algorithms. This is done as to not get any false positive for our data. There are very cases of people reporting false fires and the fire stations being expanded, but it turns out there was nothing there. And also we like to integrate more sensors like humidity, wind to improve data accuracy and reliability, and design a better interface for data visualization. So these are all the papers I referred. Thank you, and thank you for listening to my small presentation.
Thank you, sir, for your presentation. Are there any questions? We'll proceed to the next presenter. So the second presenter we have here today is AWS Pricing Structure and Cost Management, a basic comparison with Azure. This paper will be presented by Vishal Karpe from Lok Jagrati University, India. I request Vishal Karpe to please proceed with your presentation.
Yeah, ma'am. Does my screen is visible to you, ma'am?
Yes, sir, your screen is visible.
Okay, thank you. Good afternoon, everyone. I'm Vishal Garpe, and along with my co-author, Mitu Kanpal, I'm here to present a research on AWS pricing and a cost management, a simple comparison with Azure. Just imagine you are getting a car. AWS is like a rental where you can only pay for what you use it, right? As a we go for the it also get the discounts if you commit to renting it for a longer time. Now, how AWS pricing works and how businesses can manage cost efficiently. In this research, we will explore. Yeah, in this research, we have AWS price structure with in this paper, we have discussed the particular pricing model suits different business needs. As the abstract we have done within this paper is that it focuses on the AWS charges for its services, like paying only for the what you use, pay as you go, or getting a discount by committing for the longer time. Means, as we say, as saving the plans. We also compare the AWS with the Azure to see the differences and how AWS helps the to save the money. uh, Paper also explains the tools like AWS offers, like AWS budgets is there, that is AWS pricing calculators. These tools help the particular businesses to uh, track of the and manage their costs. So this is the just a simple guide to help the companies to save the money on the cloud services. As we go further, the main importance point is that the cloud, what is a cloud is an renting a car instead of buying one. Businesses can use the online storages and particular software without spending a lot on computers, yeah, devices. They only pay for the what they used, like paying for the rent card based on the hourly basis or daily basis. In these presentations, this paper we have discussed how the AWS and Microsoft Azure offer a different pricing plans to help the businesses to save the money and grow as needed. This is the total diagrams where total understanding of the pricing at a glance. Here, the first of all, there are three parts we had divided into three parts. The first is that the particular pricing AWS pricing strategies, AWS cost management tools, and comparisons with the AWS comparison with Azure. In the pricing strategies, we have done with the particular pay for what we use. Examples like paying only for the electricity we use it. And second is that we can commit and save up to 72%, like a yearly bus pass saving more with the long term plan. And 12 months free is there. The examples like a free trial is there. And the cost management tools are that, like a track costing with checking of examples like a checking of phone bills. Late limits is there for checking the shopping budgets. And the use wisely is also there, which are examples like a turning off the lights to save the particular money or to save the power. And AWS, we have also compared with AWS with Microsoft Azure. In that, we have seen that particular AWS provides the more services, like examples like a bigger mall with the many more options. And Azure is like examples like iPhone with the based with the Apple apps. So this study focuses on the particular topics as the strategies, AWS pricing strategies, pricing plans means cost management tools, and AWS comparisons with the Azure. The motivations of the paper is that the cloud computing costs are important for the businesses to manage their order to stay profitable. AWS and Azure offer different ways to charge for their services. For example, as we see that AWS charged on the usage, while Azure allows the businesses to save by paying for the services in advance. So these are some examples. And next is that what is an AWS? AWS is we have done with that. The AWS is the platform that offers many services to grow the businesses. The key aspects is like web hosting. EC2 is that. EC2 is nothing but it's run on the online store without worrying for the server space. Data storage is there. Machine learning algorithms, yeah, machine learning model is there. SageMaker, which is used for the recommendation system. Networking and security is there, which protects the websites. What is then difference of the pricing models? The pricing models is there as a pay as you go, saving the plans, and no upfront investment. No upfront investment start using the AWS with no initial cost and easily scale as needed. The AWS cost management tools. These are all the tools which will help the particular businesses, which will help the particular users. First is the of the particular AWS budgets, AWS calculator, AWS trusted advisor, AWS cost explorer. The particular budget tool is recommended for the monthly limit on their cloud costs. It will get an alert of that you will be about to exceed it. Pricing calculator is a small businesses can check it might be for the storage before using it. It will calculate a particular price before using it. The trusted advisor is that it will help the businesses to save money by suggesting ways to reduce any unused resources. Cost explorer is that the key. businesses can see their past spending and predict the future costs to plan a better. We also have compare with the Microsoft Azure. Both the AWS and Microsoft offer both as a pay-as-you-go pricing and a saving plans for long-time use. AWS has a bigger discounts than better cost tools, while Azure is great for the businesses using a Microsoft products like Office 365 and Teams. Here are the results and findings. Benefits and challenges of the AWS. Benefits, we have seen that it helps to manage the costs, like tools. We have already seen the Explorer advisor is there. And challenges, we have got that making it harder for the beginners to manage the cost. AWS versus Azure, the key difference is that the AWS is great for the businesses needing for scalability, flexibility, while Azure works for the best for the companies using Microsoft products and all.
Sir, sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Yeah, ma'am. Yeah, ma'am. The conclusion is that the AWS provides the flexible pricing and helpful tools to manage the cost. It is great for the options for the businesses. Future research can look into how these tools help for different industries and business manage their expenses better. Thank you. These are the references. If anyone has any questions.
Okay, thank you, sir, for your presentation. Now we'll proceed to the next presenter. So the next presenter of today's session is Ritvik Rana from SRM Institute of Science and Technology, India. And the paper title is Carbon Footprint Tracking Using AI. Ritvik Rana, sir, if you're there in the meeting, please respond and start with your presentation.
Yes. Yes. Am I audible?
Yes.
Okay, just I'll start. Where? Okay. Okay. Is the presentation visible?
Yes.
Okay. A warm afternoon to the panel body and to the presenting members. I'm here on behalf of my team to present a paper titled Carbon Footprint Tracking Using AI. Now, okay. Now, why did we choose this topic? The main gist of it was we were actually concerned with how are we going to forecast the rise of carbon emissions in the short term. While we have long-term solutions that use long short-term memory, graph neural networks of multiple forms, etc., we were very much concerned with what happens if you say, I want to forecast it for the next day or the next month. There's not a well-defined solution for that. So we came to this conclusion and hence we implemented this project. So as you can read the abstract, the escalating threat of climate change has made it imperative to understand and mitigate the environmental impact of human activities, which we have implemented using autoregressive integrated moving average models. The ARIMA model that we have used, it's not exactly one model, it's a combination of three models: autoregressive, integrated, and moving average, which is basically describing the trends and seasonality of your data as you as you go forward or backwards in time. So let's move on forward. And as we can see, yes, in recent years, the urgency to address global environmental sustainability has increased a lot. Now, this is obviously due to booming human population, economic activities, industrial activities, etc. Now, we can obviously let it happen, but we also need to keep a track because the side effects of rising carbon emissions include smog, which is not good for our health, and it also leads rise in acid rains, which is not good for any of our economic activities, vice versa. So, and yes, but one of our main goal objectives was also how do we implement a cheap and effective system that is plug and play mostly instead of having to train and refit the data at each and every step. So that's why we have settled on ARIMA as the answer. Now we'll go over here, and some of the limitations that we have had while implementing this project was the data that we had, the time period for it ranged from 1900 till 2022, but we needed something that went beyond 2022. So, and we didn't have access to any such official source or any such reliable stream at that point. So we could not validate the model's findings using that data. And the second limitation that we have had is data decomposition. Now, obviously, as we know that the rise in CO2 activity, rise in the environmental emissions, it's not just a byproduct of time. That means it's not just that timing, that as time passes by, the entropy of any system goes by. No, it is also due to our activities, the activities of any biological life, and the strain that we put on the ecosystem. So owing to that, if say if we were to use the same system to factor in multiple different dependencies, multiple different factors, what leads to rise in CO2, then ARIMA would prove a little more than shortcoming in that, which can be taken over with graph neural networks. But for the purpose of this research, we have stuck to ARIMA so that it can provide us cheap and reliable computing for the immediate future. Now, well, what's our methodology is we have taken a data set. We have taken a data set from an official source. It was the World Bank, and then we have pre-processed that data set. Now, pre-processing in this project, what we have done is we have checked for the quality of the data set, how many missing entries, how many non-numeric entries, because we are going to be dealing with a lot of numeric data. And we have effectively come to the conclusion that for this project, it would be better if we deal with the data ranging from 1947 to 2022. That is the data cutoff. And yeah, that's the basic pre-processing part. Now, after that, we have to go for timestamp verification. We didn't have to do much. We just had to ensure that the period that we had chosen, each of them had valid data entries, and they correlated with every other data that we had on that source. And yes, now one of the main issues that comes with, not one of the main issues, one of the main challenges that comes with fitting that data to an ARIMA model is you have to ensure stationarity. Now, when I say stationarity, it means that when you try to project a data over a trained time cycle, the model should be able to understand that yes, it is not just a one-time occurrence. It either rises, goes down, or it has a limited variance within that time frame, and that's the basic meaning of stationarity, which we that was a little of a challenge to overcome. And then we checked for the stationarity using the augmented decay Fuller test. Well, to cut the point short, we checked for a stationarity value of 0.05. We were within the approachable range of 0.07, which we deemed valid enough, given that any further decomposition would result in garbage values. And once we had deemed that the value was more than sufficient, we moved on to training the model. Now, this is a system architecture diagram. Now, let's go over how this thing functions. So data collection of the time series, as I told you, we took the data from World Bank, we curated it, and we cut it short from 1947 till 2022. Now we are going to difference the series. Now, differencing the series, it basically means you subtract the previous point from the successive point. That's it. And then we are going to forecast it over a very minimum time period as much as possible, say 1 or 2 years. Within that time period, if the stationarity fits and is well enough, we proceed with the same parameters for the overall training of the model. And this is the final output that we have got so far. We had trained a model from 1947 till 2015. Now the data ranges back from 1947 because we felt it would be little apt to show you the data all the way from 1900. And what you see onwards is from 2015 onwards. So, and that's the trend that has been followed ever since. This small bump in trend that you see, it's because of the COVID pandemic. None of the models were able to capture it efficiently unless we captured it on a LSTM. Even then, we weren't able to bring it up to a remarkable accuracy. And this is what we have projected, that it keeps on increasing at a steady rate, though it might also be a positive deviation in resulting in way more upwards curve. And so far, the results and conclusion that we have come to is this model With this model, it's easy plug and play. We do not have to tinker around much with the configurations. We can directly plug in our data, differentiate it according to our needed threshold, and then train the ARIMA network instead of having to go through multiple steps for training a neural network. Computationally, it takes way less resources and way less time to train and use it. And we can also use the predictions made by these model to check for our the impacts of our policies in the immediate short term. It's not required that we have the real time data at every point. Sometimes the sensors may be scrambled. Sometimes you may have false reports. Sometimes there may be an immediate increase in activity right around the corner. So we can just rely on the immediate present future for that. And we can also augment it with a LSTM, but for the purpose of this project, we felt it would be unnecessary and unwise to do so, as we were concerned with cheaper computation and faster computation. And yes, we hope that in future there's availability of real-time data so that we can correlate any and all findings. Thank you.
Thank you, sir, for your presentation. Now we'll proceed to the next presenter. So the next paper is Enhanced Deep Learning Model for Character Recognition of Regional Language. And this paper will be presented by Padma Priya R from Ramaya Institute of Technology, India. I request ma'am to please continue with your presentation.
Yes, ma'am. Ma'am, is my screen visible?
Yes.
Okay. So good afternoon, everyone. My name is Padma Priya, and I'm honored to present our research on behalf of my co-authors, Aditya, Amogha, and Manoj. Today, I'll be discussing our paper titled Enhanced Deep Learning Model for Character Recognition of Regional Language. This study focuses on improving handwritten character recognition for Kannada language using deep learning. In this presentation, I will cover introduction to the problem, comparison of current versus proposed methodology, results, and conclusion. Introduction. Handwritten character recognition for regional languages like Kannada is challenging due to complex scripts and limited dataset. To address this, we focus on three key aspects. What we propose, a hybrid deep learning model combining ResNet 50 and VGG 16 to enhance Kannada character recognition. Why it matters? Existing recognition tools lack accuracy and accessibility, making it harder to preserve and promote Kannada. How we achieve it? By using a diverse dataset, advanced pre-processing, and deep learning optimization to ensure reliable recognition. Challenges faced in the current methodology include limited Kannada datasets, basic pre-processing techniques, reliance on traditional machine learning models, and suboptimal training approaches, all of which affected the accuracy and adaptability of character recognition. To overcome these, our proposed methodology introduced several improvements. We curated an extensive dataset covering various handwriting styles to enhance model learning. Advanced pre-processing techniques such as unskewing, resizing, cropping, noise reduction, and augmentation included controlled rotations and shifts, ensuring Kannada characters were not distorted into different letters. For feature extraction and pattern recognition, we implemented a hybrid ResNet 50 VGG16 model, leveraging the strengths of both architectures. Training was further optimized through iterative fine-tuning and backpropagation, ensuring better accuracy. Finally, rigorous evaluation and validation were conducted across multiple handwriting variations, making the system more robust and reliable. So here's the system architecture. We first start with a data collection step where we acquire many handwritten character images for both training and testing. And then comes the data pre-processing, which includes data augmentation, unskewing, resizing, normalizing, and cropping. Next is the model training, where we use TensorFlow to train the hybrid deep learning model. And then leveraging ResNet 50 and VGG 16, we extract features, both simple and complex patterns. Next, using the extracted features, we classify to recognize various characters. Next, in the model evaluation, we validate the model accuracy using test data. Finally, we deploy, that is, we run the trained model on local server for testing and usage. Here's a proposed hybrid model architecture. So as seen in the diagram, the pre-trained VGG16 and ResNet 50 layers are not altered and are kept as it is to fully utilize their character recognition abilities. On top of each, we have added a 4096 neuron layer followed by a 2048 neuron layer. The extracted features from both models are then combined into a 8192 neuron layer, which is further reduced to 4096 neuron. Finally, a softmax layer to predict the character. Reason for choosing this architecture. We selected VGG16 and ResNet 50 for their complementary strengths, enabling the model to capture both simple and complex features effectively. Both models excel in computer vision, enhancing feature extraction and pattern recognition. This architecture hence strikes the right balance between accuracy, adaptability, and computational efficiency. Results. We evaluated our model against individual architectures. So as seen, the ResNet 50 base model achieved 82% accuracy. VGG16 base model achieved 86% accuracy. Our hybrid model outperformed both, achieving 91.7% accuracy. Here's the UI of our website. The user has drawn the letter Ya on the white canvas, and the model has correctly predicted it. We also built an interactive learning tool for this hybrid model where the system reads out a letter and the user must recognize and draw it. If they both match, they earn points. So this tool is beneficial for both research and education. Conclusion. To summarize, we developed a deep learning based Kannada handwritten character recognition system, achieving 91.7% accuracy using a hybrid ResNet 50 VGG16 model and a user-friendly interactive web tool for language learning. Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next paper title is Fortifying the Future, Cybersecurity Strategies for Critical Energy Infrastructure. This paper will be presented by Eddie Diong Ek Pabio from Datta Mega Institute of Higher Education and Research, India. Sir, if you're there with us, please start with your presentation.
Okay, please give me some time while I share my screen.
Yes, sure.
Turn on your camera.
Yeah, it's on now. Yeah, is my slide visible, please?
Yes, sir, your screen is visible.
Okay. Yeah, please give me some time while I share the entire screen. Okay. So, good afternoon, everyone. My name is Edidion Pabio, and I'll be presenting on the topic Fortifying the Future Cybersecurity Strategies for Critical Energy Infrastructure. And these are the table of content. We'll look at the introduction, literature review, the cybersecurity threats, the challenges, the strategies, the emerging trends, conclusion, and then finally my references. And then, so now let's go to an introduction of this. So advanced, so please give me some time, my screen is having some problems. Yeah, so advanced interconnectivity among energy sector components via the international Internet of Things, cloud computing, and advanced analytics. They are expanding the critical energy infrastructure attack surface. And also these attacks can cause physical loss, damage to equipment, and then facilities or explosions can happen which are catastrophic to the environmental disasters. And also the goal of this paper is to contribute to the current protection of these critical energy systems against emerging and evolving cyber threats. So now let's look at a brief history of the literature review. So we like seeing that an author Jovi et al. Had said that it's useful to bring AI into cybersecurity practices, which can help be a transformational approach towards cyber. And also, Adebite et al. Also analyzed the different strategies that USA have employed in relation to securing the natural infrastructure. And then also, JAR also talked about the communication infrastructure that are used in power grids. And then he also highlighted the fundamental cybersecurity challenges as well. And then finally, Zudik also talked about that the critical infrastructure has an increased dependency on ICT, which enables it to work effectively. And now we look at the cybersecurity threats. There are different threats that are defined in terms of the physical threats, the network threats, the encryption threats, as well as the software threat. Well, we'll be looking at these three for today, which are the ransomware, where a system is held to a ransom that you have to pay an amount of money before it's being released, and such like the power grids, the pipelines, and all refineries that are happening in different advanced countries in the world today. And also we look at APTs where that are happening because of the national state actors, where countries come together to attack a different country. We see Israel and Iran fight with USA. And also we look at DOS, which is the distributed denial of service, where different requests are being sent to a particular energy infrastructure, which causes it to shut down. And then what are the challenges in securing this? We see the complexity in energy systems. Actually, they're actually very complex, talking about SCADA, the programming logic controllers, as well as the industrial control systems. All these which suffer huge security attacks. And also we depend too much on physical as well as cyber components, where we can see that, which is the Stuxnet attack, where malware was used to target particular public limited companies, and as well as at an Iranian nuclear facility, which caused centrifuges to rupture physically. And then also the strategies for securing this, we need to do some risk assessments, network segmentation, as well as bring something called intrusion detection and prevention system. And then also the emerging trends. What are the new things that are coming on? What are the new things that will be happening in future? We hope to see artificial intelligence and machine learning in threat prediction, where we can feed it different models of data pertaining to the threat, and it's going to analyze it and then give us feedback when a malicious act is being happened. And then also automated response, where we can see that the machine learning or the AI robotic infrastructure can block particular network traffic in terms of DDoS and others. And also blockchain as well for securing transactions, which will help for decentralization, where they will keep track of the transaction records. And then also it doesn't have a single point of failure, because this is actually very safe. And also we will have smart contracts as well, which are self-executing contracts with the details of agreements codified directly into lines. and then which will get rid of human errors and fraud manipulation. And then in conclusion, protecting critical infrastructure is no longer a necessity for operation, but rather it's a matter of national and global security. So like we need to do continuous incidents monitoring, security protocol upgrades, as well as the integration of incident response and disaster recovery plan like IDPS and the rest. And also, if you can see a collaboration between public and private sector, so they can also safeguard these energy infrastructures. And so these are some of the references where I got my point from. Thank you for your time.
Thank you, sir, for your presentation. If there aren't any questions, then I'll proceed further. Okay, so the next paper is Harnessing Machine Learning for Eggshell Powder Shampoo Formulation in Hair Health. And this paper will be presented by Archana Rane from KK Wagh Institute of Engineering, Education and Research, India. I request Archana ma'am to start with the presentation.
Excuse me, Siddhi. This is Upesh Patel, session chair, joining late. I'm sorry for that. I think I am the part of this, right?
Yes, yes. Good afternoon, sir.
Good afternoon, everybody. You may start with the process. I mean, I am here.
Yes. I request Archana ma'am to start with the presentation.
Yes, ma'am. Please allow to share the screen.
Yes, yes. I've stopped sharing my screen now. You'll be able to share.
Yeah, thank you. Good afternoon, everyone. I, along with my team, Mrs. Archana Rane, Sanskruti Toyale, Rasika Ghaute, Aditi Khairnar, and Harisha Chotwani, will be presenting a research on harnessing machine learning for eggshell powder shampoo formulation in hair health. In this study, we explore the innovative use of eggshell powder in shampoo and how machine learning can optimize the formulation to improve the hair health. Let's dive into more details. Hair health is an important concern for many individuals, and finding the right shampoo is often challenging. Many commercial shampoos contain synthetic chemicals that can cause long-term damage to the scalp and hair root. Our research focuses on alternative approach using eggshell powder as a natural ingredient in shampoo formulations. Eggshells are rich in calcium and essential minerals, which are beneficial for strengthening hair and improving scalp health. However, the challenge is determining the right concentration and combination of ingredients for the best results. This is where the machine comes into the play. Instead of relying on trials and error methods, we use advanced algorithms to optimize the formulation efficiently. Here is the abstract of our paper. And the key outcomes are eggshell powder shampoo demonstrated improved the hair strength, moisture retention, and scalp health. The study also highlights the sustainability of eco-friendliness of eggshell powder as a viable ingredient for natural hair care product. Aligned with the consumer demand with sustainable and environmental conscious for the personal care solutions. Literature review. In our literature review, we have studied previous on hair health natural shampoo ingredients and machine learning application in formulation sciences. We also identified a gap in research regarding the use of eggshell powder in hair care and the role of machine learning in optimizing formulations. The problems which we addressed during the studies are the lack of effective natural ingredients in commercial shampoos. Second, the use of synthetic chemicals which can harm hair in the long term. Third, the mineral deficiency in many hair care products. Fourth, the growing consumer demand for sustainable and eco-friendly solutions. By incorporating eggshell powder, we aim to provide a natural, sustainable, and effective alternative while using machine learning to optimize the formulation. The system which we have proposed for making the formulation is preparation of eggshell powder Then, for shampoo formulation, the eggshell powder was incorporated into different shampoo formulation with varying ingredient concentration. Third is experimental design, in which machine learning models were used to analyze the effect of ingredient combinations. Fourth, evaluation. The formulation were tested for the hair health benefits, texture, and scalp compatibility. By systematically analyzing the ingredient interaction, we ensure an effective and when balanced formulation. This is the building block proposed of our system. The eggshell powder. It is a natural source of calcium and minerals. Surfactants, which is essential for cleansing the scalp. Conditioning agent helps in improving hair texture and moisture retention. Preservation and additives are used to maintain the shelf life and enhance the formulation. And machine learning models are used to analyze the ingredient effectiveness and optimize concentration. So the benefits which we receive from our proposed plans are environmental benefits. Utilizing eggshell powder promotes waste recycling. Second, scalp exfoliation. Eggshell particles help in gentle exfoliation, removing dead skin cells. Third, mineral enrichment, which provides essential nutrients like calcium, proteins to strengthen the hair and to make the hair smooth. Fourth, improve hair texture. The formulation enhances smoothness and shine. Results. Using machine learning, we have evaluated the effects of different concentration of eggshell powders on the hair and scalp health. The key finding includes first, improve model accuracy, ensuring optimized ingredient ratio. Second, ROC curve analysis, which is validated the effectiveness of our formulation. And third, performance metrics showing improved health strength and scalp health compared to traditional shampoo. The results confirm that the machine learning significantly enhances the formulation process, making it more efficient and data-driven. In conclusion, a research demonstrate that eggshell powder is viable natural ingredient for hair care and machine learning can optimize its formulation for better results. Our approach is not only to enhance hair health but also support sustainability by purposing waste material. For future research, we aim to conduct clinical trials to validate long-term benefits, explore additional natural ingredients for enhanced formulation, expand machine learning application to other personal care products, and by continuing this research, we hope to contribute the development of effective, sustainable, and innovative hair care solution. And these are the references from which we studied the idea of eggshell powder shampoo. Thank you.
Thank you, ma'am, for your presentation. Now, are there any questions from the session chair?
Yes, Archa ma'am, I mean, do you have a comparison of anybody have done a same task before or the
No,
implemented algorithm with this one? Or this is completely new, whatever you
it
do?
is completely new, sir.
Then how you, with which particular reference you are going to compare your result?
Actually, we took the information from the paper which was related to the shampoo, conventional shampoos, and also from the properties of eggshells. The papers related to eggshell properties.
What should be the additional scope into this in future?
Hmm. So eggshell is more like not used, and many of the people don't have knowledge about eggshell. All of them make it a waste. So it can be a new innovative idea, and in this personal, it is also environmentally benefited.
Okay. Okay, fine. Thank you.
Thank you.
Thank you, ma'am. Thank you, sir. Now I'll proceed to the next presenter. So the next paper title is Impact of AI on Social Services, Opportunities, Challenges, Future Directions. And this paper will be presented by Vidhi Akash Pandya from Lok Jagriti University, India. I request Vidhi ma'am, if you're there in the meeting, please respond and start with your presentation. I think she's not there in the meeting.
Yes, ma'am. Yes, ma'am. Hello.
Okay, you're there.
Yes, ma'am.
Ma'am, I'll stop sharing my screen, then you can start with your presentation.
Okay, ma'am. Hello. Am I audible, ma'am?
Yes, ma'am, you're audible and we can see your screen.
Okay. My research paper title is Impact of AI, Artificial Intelligence on Social Services, Opportunities, Challenges, and Future Direction. Here is my index page and motivation. AI transform industry, reshape our problem-solving approach, and open doors to end. Artificial intelligence is not like we will see that artificial intelligence is everywhere. So it is stand as a beacon of inspiration in today's world. Hello.
Yes,
Hello.
ma'am, you are audible. Continue with this one. If possible, try to put this into full screen mode and carry on with your presentation.
Yes, ma'am. Yes, sir.
Please continue with your presentation, madam.
Yes, sir. 1 minute, please.
Press F5 if possible, or else this is fine.
Sir, wait a minute, please. Sir, my screen shown.
Yeah, it is there, not in a full screen, but that is also fine. You may continue with this, please.
So the ability of AI to analyze vast amount of data, learn patterns, and make decision or informed decisions or cases. It transformative power. The motivation us to think beyond traditional boundaries, embrace creativity, and use technology as force for good. By integrating AI into our endeavors, we have the potential to drive positive changes, make life easier, and contribute to building a smarter, more sustainable future to generation to come. Impact of AI on social services. In this paper, we explore the multifaceted impact of artificial intelligence and we highlight some area like healthcare, education, environment, and agriculture. Here are the aspects. Healthcare focus on personalized treatment, diagnosis, disease prediction, and ethical concerns. In education, we are put on the voice assistant, virtual mentors to enhance the diversity and the personalized learning. In environment, we are revolutionizing the environment research with application in wildlife tracking, habitat assessment, biodiversity analysis, and disaster prediction, enabling efficient conservation efforts. In agriculture, there are crop and soil health monitoring, drone-based precision farming, and voice-based advisory system. Introduction. There are two types of AI. Narrow AI, in which we can perform some specific tasks, like we are using now Alexa and Siri, self-driving cars, etc. In general AI, there are mimics of human intelligence for problem solving and learning. There are some from Turing test to deep learning. Alan Turing introducing the Turing test in 1950 to assess the intelligence of machine by evaluating their ability to engage in human-like conversation. In ELIZA, Joseph Weisbaum developed ELIZA in 1960, expert system in 1970 to 1918, and the deep learning revolution 2010 to yet. Literature review. AI is transforming industries like healthcare, finance, education, manufacturing, and cybersecurity by enhancing automation, decision making, and predictive capabilities. There are some challenges are also there for like data privacy concern, algorithm bias, ethical dilemmas, and the need of for explainability in AI model. Surveyor explore AI adoption trends, barriers to implementation, and industry specific application. In this research, we provide the current state of AI, its limitation, and future direction for innovation. AI in healthcare. Like we take in AI in healthcare, right, can analyze the medical images. With the use of AI, we can analyze the medical images, patient data to enhance the accuracy of diagnosis and identify the abnormalities. With the use of AI, we can we can see that in UK, National Health Service helps professional to monitor the vital signs like blood circulation of patient and, for example, blood pressure, oxygen level, and other vital signs of the patient, and in real time. So we can enable the for early detection of any disease. Explainable AI ensure the transparency in clinical diagnostics and reduce the bias in medical models. In early detection, personalized treatment, and cancer diagnosis, but faces trust issue in global adoption. For example, we can take a example of medical imaging AI can analyze the X-rays, MRI, and CT scan more accurately and quickly than the doctors. The predictive AI models can access the patient risk factors and suggestion for preventive treatments. In education, we can take example of virtual mentors. In this, we can provide the personalized learning experience, offering practicing exercise, test materials, and analyze of students' learning. In like a voice assistant, we can provide the interactive learning. We can student can learn remotely, and concept in learn in their language and allowing students to search for materials. Accessibility and inclusion, AI technologies like telepresence robotics enable students with the special needs to attend school remotely, promoting inclusion and access education. In environment protecting, for protecting environment, AI is also used like AI algorithm analyze the data for camera traps and GPS to track the wildlife movement and estimate population size. And in camera trap data, we can say that wild to automatically capture images and video of animals as they pass by. These devices are often set up in areas where wildlife is likely to roam, including protected parks or remote areas. For example, in natural disaster prediction, we can early warning of flood, and empowering communities with the better preparedness and evacuation efforts. In agriculture, we can monitor our crop and soil for if any disease in soil or
Ma'am,
in a, hello.
sorry for the interruption. We are past the presentation time. Could you please get to the conclusion?
Yes, ma'am. So AI has the potential to revolutionize social servicing, creating a more equitable and efficient for society. By addressing ethical concern and fostering responsible development, we can harness AI power to address societal challenges and improve the lives of individual and community also. Thank you, ma'am.
Thank you, ma'am, for your presentation. Now, are there any questions or shall I proceed further?
The no questions are there. They are just a suggestion that Arjuna madam, whatever the presentation you have given, these are just an application of AI into different domain, and which is readily available everywhere into internet also. So next time, please, when you are going to present something in conference, you must be having some focused result type of output must be shown over there, right? These are just an application which is collaborated together and just presented. So this is just a suggestion, by the way. Anyways, thank you.
Okay, sir.
So the next paper is on mental health detection using EEG signals. And this paper will be presented by Yash Dargude from SCTR's Pune Institute of Computer Technology. I request Yash Dargude to start with his presentation.
Sure, ma'am. I'm trying to share the screen, but yeah,
Now you'll be able to.
yeah. Is the screen visible? Like, just let me.
Yes.
Okay. So hello everyone. Myself Yash Dargudi, along with my batchmates Zui Ambikar and Yash Gadak, are here to present our research on mental health detection using EEG signal. So throughout this presentation, we'll be going through how using EEG signals and our ML models will be able to detect one person's mental health with excluding the need to consult a doctor. So we'll begin with the presentation and we'll just understand what actually mental health and EEG signal means to just correlate with each other. So mental health disorders are conditions that affect a person's moods,
अरे
thinking, and
ये
behavior,
उसने क्या बोला दिया
such
ये
as
सही पर
depression, anxiety, and schizophrenia. So,
अरे
mental health is
उधर
a
भी तो
critical
कोई है
aspect
ही
of
नहीं
human well being, influencing how we think, feel, and behave in our daily lives. In recent years, mental health disorders have become a growing concern worldwide, with conditions such as depression, anxiety, and schizophrenia in different age groups, especially in the teenage age group. So, according to the World Health Organization, one in every eight people suffers from some form of mental health disorder. These conditions can lead to severe consequences, including reduced productivity, strained relationship, and even increased risk of suicide. So, one of the traditional method which we use to detect the mental health is to consult a doctor. So that is one of the limitations of current mental health assessment method. Is so this is so with help of this ML model and using the EEG signal, we'll be able to detect the person's mental health. Just there is no need to like do a self assessment through a doctor thing. So to understand what EEG signal is, so EEG refers to electroencephalography. It is a method to record electric brain activity of a person. It is a non-invasive technique used to record electric activity. It measures brain signal through electrode placed on the scalp of our head, detecting voltage fluctuation resulting into neural activity. EEG provides valuable insight into the brain functional state, and it is widely used for neuroscience, cognitive research, and medical diagnosis. Unlike MRI and CT scan, which provide a structural imaging of the brain, EEG focuses on real-time functioning activity, making it ideal for detecting monetary changes in mental state. This real-time monitoring ability allows researchers and clinicians to study how the brain responds to emotions, stress, anxiety, and cognitive tasks. So how EEG support mental health research? It provides measurable indicators for conditions that are typically assessed subjectively. Applications in AI and machine learning. So advanced algorithm which will be using intercept EEG data, aiding in accurate mental health detection. So there are different like when EEG signals, there are different electrowave activity which we are able to segregate, and then we are able to detect like if the person is going through a depression or anxiety. So these are the frequency bands which are distinct. So the first one is the delta wave, which is linked to the deep sleep and unconscious state. Theta wave, which is associated to drowsiness, daydreaming, and meditation. Also, the alpha wave are related to the calmness, relaxation, and alertness, wakefulness. Beta waves found in active thinking, problem solving. Like as such, if we are given a problem to solve, the beta waves would be active, and we will be able to detect he is trying to solve a complex problem. And gamma waves is in high level cognitive processing and perception. Below is the image attached how the neural electrodes activity look like. So these are for the first one is for the gamma, beta, alpha, theta, and delta. So to detect the like depression, the gamma, if we are observing gamma waves in the one person's neural activity, we can detect that the person is suffering from depression or anxiety. So what are the common health indicators? Are depression, anxiety, stress, and cognitive disorders. So as we discussed that EEG signals, we use an EEG signal machine detector which we place on our scalp, and throughout that, it places various electrodes throughout our scalp. There are different. We can segregate into different sections Like there is a prefrontal section, occipital cortex, partial cortex, and frontal cortex. So basically, it will be placing all around the scalp in 16 different regions to detect different neural activity of our brain over here. So from the given image, you can see all the like these all are the electrodes placed on the different parts of the brain. Then so how using the EEG signal we'll be able to detect mental health. So yeah, so the main block diagram, so what we'll be using is uh, using the EEG signal machine detector, we'll be acquiring the data, which is the data set we'll be having, and to pre-process the data set. So the most challenging part of this implementation will be the pre-processing part. So brain activity are very uh, it changes a lot. Like if there is a blink of an eye or a muscle movement or any movement from the body, it indicates it indicates a spark in the neural activity, which causes the data to be fault. So to pre-process, to clean the data, and from raw data to get a very clean data for the further ML model to detect the mental health is very necessary. So this is one of the challenges we face throughout the project. So why to use machine learning in EEG signal? So machine learning plays a crucial role in analyzing EEG data by automatically detecting patterns and features that are difficult for humans to interpret. It enhances the accuracy of mental health detection by classifying brainwave signals and enabling personalized and efficient analysis for improved diagnostic and treatment planning. So, to detect the EEG signal previously, SVM, which is support vector machines, SVM, neural networks, K nearest neighbors, and random forest. Various algorithm has been used to accurately
Hello.
predict the mental health of a person. Hello, ma'am.
Sir, we are past the presentation time. Can we please get
Yeah,
to the
I'll
conclusion?
yeah, yeah,
Yes.
yeah. I'll just so if we can just see into the slide, these are the different algorithms used, and the on the y-axis we observe that there are the accuracies. So using 3D CNN, we achieve the maximum accuracy. So throughout this project, we'll be using 3D CNN. So I'll just explain the basic chart forming. We'll be data pre-processing, then we'll be just feature extracting. What are the features we want to extract from there? Then feature selection. If we want to detect anxiety, we'll choose that feature and we'll be using that model for the evaluation. So this is how the flowchart looks like, and so the sum the result is highlighting machine learning models for EEG miss mental detection. We focus on algorithm features and dataset. Here, the dataset plays an important role in detection of. This is how we develop a system for accurate, non-invasive, real-time mental health detection. These are the references we have used in our throughout our research paper. And yeah, thank you.
Thank you, sir, for your presentation.
Thank-
Yes. Have you developed any of the algorithm for the same, or you just have to?
so Yes, so for right now, what we are, like it is an ongoing process. So right now, what we are trying to do is we are trying to gather as much as data set as possible. Like we have referred from Kaggle, along with there are some website where the scientists people they have used that data set, like a data set where
Are
like
you in a
it
process
is
to
a
develop
record.
any new algorithm, right?
Yeah, nee, what we'll be achieving, all these algorithms have been used, but we will be able to achieve more accuracy than them by referring to different data sets. That is our aim, to achieve greater accuracy.
Uh, so you mean to say that you are going to use a different types of data set with the same techniques, and you are trying to improve the accuracy? Is it so?
Right, like we'll be using 3D CNN and we'll be
The
referring
more
to as
convenient
much.
approach is the more convenient approach is whatever the available database, you have to develop a new technique to improve the accuracy. That would be the new approach, I guess. Anyways, I mean, this is also
Uh,
good. And one more suggestion is there: when stipulated time are given to you, you just have to focus more on technical part rather than just giving an introduction about EEG and all other things. So whatever the
Right.
algorithms you wanted to implement, what are the databases you are going to have, you have to focus more on that rather than wasting time more into the introduction about EEG and other things, right? So by looking at the time limit, you have to present your presentation. Anyways,
Sure, sir. I'll take care of it.
sure.
Thank you.
So the next paper title is Plugin Based for Traffic Analysis, a deep learning approach for identification of orchestrated for traffic. And this paper title will be presented by Krishnan Pal Singh from Malavia National Institute of Technology, India. I request Krishnan sir to please proceed with your presentation. I'll stop
Yeah,
sharing my screen.
sure. Am I audible?
Yes, sir, you are audible.
Okay. Is the slides visible?
Yes.
Yes, sir, slides are visible.
Okay. My name is Krishna Pal Singh, and I'm presenting the paper on plugin based traffic analysis. Uh, the authors are Krishna Pal Singh, Emmanuel Pilli, and Vijay Lakshmi from Malvin National Institute of Technology, Jaipur. These are the overview. First, we'll go about the introduction, then the research question, the primary contribution. Then there will be the plugin based or traffic analysis, our methodology, what are the results, and what were the analysis. Then the conclusion and the future work. So what is TOR? TOR, the Onion Routing Network, stands for a cornerstone for ACN, Anonymous Communication Network. There are different ACNs. I2P is one, ZeroNet is one, PreNet is one. TOR is mostly used for anonymous, like in countries where surveillance is a very big thing, and a user have to bypass the network surveillance. They have to look for a avenue to access the internet without being in the books of the government and all. So Tor is working on currently with 14,000 nodes worldwide with the 2 million users daily, 2 million users daily, and it is a decentralized network. Tor masks its traffic using the plugins. We call it pluggable transports. There are six type of pluggable transport. One is FT, then there is a MEAG, then there is a Snowflake, Scramble Shoot, then OBFS4 and OBFS3. These masking is done using random delays, data padding, and packet truncations. These are the characteristics of different Tor plugins. These are only six plugins that are being used in Tor right now, Tor v3. Uh, Mostly used plugin is OBFS4 and Snowflake right now. Both almost work on DTLS using WebRTC, uh, real-time communication with the padding of SAR 256 and 128 with hashing. These were the three research questions we wanted to address for our paper. First, what if do the pluggable transport effectively conceal the entire Tor traffic from analysis, or there are still vulnerabilities in the Tor traffic? Uh, can we analyze the single packet analysis of Tor? Can deep learning mechanisms identify the single packet analysis of Tor packets? These are the primary contribution of our work. We introduced the custom-built traffic collection environment to collect the real-time data so that we don't rely on the old and outdated data sets because two of those plugins have been recently introduced after 2021. OBFS4 is a 2021 plugin and Scramble Fruit is another 2022 plugin. So there is not a lot of data sets available, and the reliability of data sets are also a big issue for concern. So we collected our own data set, and then we proposed the identification mechanism to analyze the data using the stats properties single packet analysis. The overview of proposed framework, we have to identify store plugins using their characteristics and the fingerprints. Each plugin has different characteristics. So we base our research on handshake payloads and the timing behaviors of each authentication mechanism the plugins are using, such as Scramble Shoot has a very strict authentication mechanism, so it takes much time, and it is easily detectable that the person is using Scramble Shoot. OBFS4 use filter traffic using expected packet length rate. So we can identify that also. This is the proposed framework. We have to modify the Tor RC using the Python script, and then the Tor gateway. The data was collected in the PCAP file, monitored using Wireshark and TCP dump. The data was then translated into CSV file. We analyzed the handshake package. The classifier was used to analyze the payload features and 6 different plugins to identify whether the traffic was non-Tor or Tor. The data collection process was done using 2 ports, 1080 and 9050. The the entire traffic was asked from the Tor project itself using the bridge at torproject.org. Tor provide you the plugins. Tor provides you the data also. The obfuscator Snowflake was configured to capture Tor traffic for correlation analysis. These are the hardware specifications. We use the Linux Mint Cinnamon because Mint is a very lightweight Linux operating system. VLAN was used, and TCP dump and Wireshark were used to capture the traffic, and different Python libraries were used to analyze that traffic. So this is the existing data set, ICXT Tor, which is a 2016 data set, and the collected traffic is our data, where we collected the OBFS4 of a normal package and the onion service packet, and also Snowflake for normal and the onion service packet. We just collected the traffic from those 2 plugins, and the existing 4 plugins we could use from the previous data set. The payload features was analyzed on various formats, binary, hexadecimal, and ASCII. The base 16 number system was used. 2 datasets was classified into DF and F. The first one was to collect the uh, frequency of each hexadecimal character distributed in the payloads, and the second one was to use the rank of each character's frequency using the payload. Then we used the complementary error function, p-value. We calculated the p-value. The similarity test was done using cosine similarity, and the threshold was set around 0.8. These are the features extracted from the Tor traffic: the source port, destination port, the IAT, the inter-arrival time, flow bytes, packet size, packet intervals, and the ideal and active standards. These are the accuracy rates of our collection mechanism, of our identification mechanism. We could easily get a good accuracy because we had to do the handshake and the timing analysis. We had some high false positive rate in FTE because FTE is just a file encryption mechanism. So it is not basically a Tor plugin, but Tor has implemented it in its previous versions. These are the performance comparison. These are the results where we could achieve 95% accuracy for me, 98% accuracy for OBFS4 and Snowflake. We achieved a low false positive rate around ranging from 0.1 to 0.5, and these are the different interval sizes. These are the comparison on our data as well as the previous data set to study that our data set has the accurate representation of Tor traffic just as the previous data sets were. These are the training and validation laws.
Sir,
Yes, yes,
could
ma'am.
you please get to the conclusion? We are past the
Yeah,
presentation time.
yeah, ma'am. This is the conclusion. Yes.
Yes, yes.
Yeah. So we compared our result on ISCX Tor dataset and our dataset, and the comparison was shown in this figure. So we could identify Tor traffic. For the minimal gap between the training and validation is a representation that our data identification mechanism can very well function in real Tor traffic collection and identification. We has a high accuracy in both data sets, and we has a decreasing trend of curve in false positive rate. These are the comparison with contemporary works. Here, the recent most work was Mezina and Chens, and we could achieve better accuracy than both of their works. The future work is aimed on analyzing the Tor fingerprints and analyzing the adversary attacks on Tor. These are the references. Any questions?
You have mentioned somewhere that you have used some real-time databases, right?
Yeah, I've collected a data set of my own using OBFS4 and Snowflake. We just requested Tor to provide us the data so that we can monitor those plugins on our isolated environment.
How many samples are there? How many sample you took in
Uh,
one database?
Yeah, the packet samples for normal packets was around 20,000, and the onion service was around 32,000 for our collected traffic, and the previous data set was around 80,000 packets.
Okay, so what are the results you will be getting based on these data sets? Are satisfied or not?
Yes, I think that we have achieved a good accuracy in the data collection, as well as we could collect the data. It was the big thing in a Tor that you could identify the traffic, and the identification ratio of OBFS4 and Snowflake has to be higher because OBFS4 and Snowflake are the recent most and the mostly used plugins on Tor, and Tor mask is traffic as such, so that the all the traffic looks similar to the passive listener. So we could identify the traffic that this is using OBFS4 and this is using Snowflake. And the further is that we could collect the fingerprints of different plugins. And now we can analyze those fingerprints to identify which relay was used, which entry point was used, which exit point was used, what is the packet size, what is the encryption mechanism used. We are doing that in our future work, current work.
Okay, fine, Krishan. Thank you. Good work.
Yeah, thank you. Thank you.
Thank you, sir. Now I'll proceed to the next presenter. So the next paper is on prioritizing SHE packets for emergency response. And this paper will be presented by Babu Singh Ram Singh Rajput from KLE Technological University, India. I request sir to please start with your.
Yeah, Siddhi ma'am, am I audible?
Yes, yes.
Okay, I will share the screen. Ma'am, if you stop sharing, I can share the screen.
Yes, I'll stop sharing.
Okay, I am here behalf of my authors presenting you the our project, product, or our new methodology that is titled as prioritizing SHE packets for emergency response. So if you look carefully, it has two subtitles in it. One is prioritizing SHE packets and another one is emergency response. So emergency response, I'm referring to any network disaster occurs. For example, like a heavy storm or heavy rain, that time a network may fall unworking. That time we are managing that particular situation and prioritizing important packets. So we'll directly jump to the problem statement, which has addressing the challenges of maintaining resilient network infrastructure during the disaster, ensure uninterrupted communication and data transfer between source and communication. So we'll directly go to the before jumping into this topic, we have gone through many research papers, but we made sure that the network disaster management part have no one done before. Many have done or few have done the prioritizing the packets, but no one have done the network disaster management. So due to time constraint, I will not go deep in these research papers. I will directly explain about the gaps. These papers are either efficient or reliable or faster for a better real-time response. If it is a better real-time response, it has a very high chance of packet loss. If it is a reliable but it takes due to the delay is high, it is not considered as a real-time response. So what we were doing is I will introduce our methodology. We have created one network and we have placed one router in between it, which divides that particular network into two separate hubs. We have named it as one network A and one is network B. Network A consists of or connected some few devices, and network B also connected to few devices, and all those few devices connected to that particular corresponding network are interconnected to each other in same as network B and network A. So what our aim is to, for example, let us say the one device that is laptop of switch one is wants to send 10 packets to the PC of network B. So in that, the SH packets, which is named for security, health, and emergency packets, are let us say sixth packet, eighth packet, and ninth packet. So the packet delivery will be held in such a way that first come first served basis. For example, the first packet which comes will be sent to the first will send first to the destination. So what we will do, so let us say one example. Suppose say packet 1 sent, packet 2 sent, packet 3 sent, and packet 4 sent. Yeah, after the sending of packet 4, the network disaster happened. Now we have left with 6 packets. So what happens? We are referring network disaster means we completely doing this in virtual mode. So we cannot create a physical infrastructure damage. So we are removing this particular link between laptop 1 and switch 1. So as these all devices are interconnected to each other, the remaining packets it handovers to the nearby devices. Let us say in this case server 1. Now remaining 6 packets need to be sent to the PC, which is destination. So in that remaining 6 packets, we do prioritization based on SHE packets. So we are differentiating those packets in SHE and non-SHE packets due to some prioritization techniques. I will explain that technique later. So after prioritization, let us say sixth, the packet need to be sent is fifth according to the first come first served basis. But after the prioritization, as SHE packets of higher priority means which is sixth, seventh, and eighth packet, those packets will be sent first after followed by non-SH packets, which are normal packets. So the block diagram is simple. We are created a network and data transmission begins. After, we have destroyed the link, and after destroying the link, the device finds the alternative path by nearby device. And after prioritization of SH packets based on DSCP bits. DSCP bits are nothing but it's one method or with comes in IPv4 headogram at the type of service field. It's a differentiated service code point. It has own precedency levels like 0, 1, 2, 3, 4, etc. and have unique decimal values and has its current corresponding binary value and have DSCP name for each bit or each binary code or decimal point. So by this way, we can prioritize that those SHE packets between non-SHE packets. So we are using Mininet for this implementation so that we can create elements like switches, hoods, controllers, and links virtual mode in virtual mode. So algorithm is so simple. We have beginning of the software that is start, and we have created one network. We have placed a router in between, which created divide that network into 2 networks. And if link is not destroyed, means network disaster not happened, the packets are moved in a normal way. If the link gets destroyed, means meaning to network disaster happened, host finds first alternative way to transfer packets, and after getting that path, it is prioritizing those SHA packets as a higher priority so that they can be transferred first, because SHA packets need to be transferred first. For SHA packets are, we can refer it as SOS calls like contact number of police, contact number of medicals, etc. So it's the implementation image or as a screenshot of we are created a network image, and here you can see this is before the before network disaster. So before prioritization of packets, then you can see the name of DSCP is unknown because the prioritization is not yet happened. And when now we have destroyed one link between source host and that switch. So after that, we in this we are referring we are giving precedency of 5 and a decimal value of 46, which has a name of EVF. We are considering it as an SHA packets. So we are sending those 5 packets, and after that non-SHA packets, which has a decimal value of 0.5 and which 2 packets of a decimal value 42 and 2 packets decimal value of 10. So as this network disaster already occurred, so SHA packets need to be prioritized and sent first. So the next packet which send will be EF according to the SHA packets, according to the DSCP sheet. So you can see here DSCP. Now the third frame says that it's as a DSCP name of EF, means it is a SHA packet. So the next frame also it is a frame 5, which it is also a DSCP packet, as we have sent 5 packets. So from now, all the remaining packets need to be sent first, which are non-SHA packets. So we gone, now you can see the packet sent was 15 packet was CS0, which is a non-SHA packet. And same way, The same way DSCP name is AF11, this is also a non-SHE packets. So this was our way to solve this challenge in a most effective way. So any questions or any suggestions, sir?
Which simulator you have used for this?
We have used Mininet, sir, in Ubuntu.
Okay, and what do you mean exactly by SHE?
SHE, sir, S referred as a security, H referred as health, and E referred as a emergency packet, sir.
All right, thank you.
Okay, sir. Thank you.
Now we are done with all of our presentations today. Now we'll proceed to the closing remarks. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of this conference. We will be happy to see you all in the 10th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. Lastly, I also thank our session chair, Dr. Upesh Patel, for chairing this session.
Thank you, ma'am.
A token of appreciation to the chair on the behalf of Team SmartCom 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Now, before ending this session, I would request all of the participants, along with the session chair, to please turn on your cameras so that I can take a quick snapshot of today's virtual conference. Okay, I've taken the snapshot. Now we can end this session. Thank you all for being part of this conference.
Thank you. Thank you.